This video has 4 practice problems for you guys to go through to review for the upcoming test. So go ahead and just pause the video right now, copy down number 1, and find all possible functions f with this given derivative. And if you need more time, just pause the video again. Let's see what you're coming up with. So the only function, when we take the derivative of this, will give us secant x tangent x, and that would be secant x. But just to show all possible functions, we just put a plus c for plus any constant, and that's it. All right, for number 2, I have 2 examples pertaining to this, and I'm asking you to find the value of the derivative graphically. So what that means is you're just really finding the slope of the tangent line if it exists at each indicated extremum. So you're either you just want to write out slope of the tangent line, or f prime of x is equal to this at each point that I'm indicating here. If it doesn't exist, you could just say the derivative does not exist at the indicated point. So pause the video and give this a try. All right, so let's see what you're coming up with. For A, we could just say f prime of x, and the indicated extremum here is going to be this point at negative 3, 4. And because it's a corner, we would just say our derivative does not exist, or it is undefined. We just say at the point negative 3, 4. Over here, for example B, at 2, 5 and 7, 1, there's our absolute or our relative max and min, rather. And if we were to draw in tangent lines, their slopes would be 0. So we could just say f prime of x is equal to 0 at both of those points. So we say at 2, 5 and 7, 1. So this is going back to that GIF 4, 1. I believe it was the problems 1 through 6 off of that, so that's all we're doing here. All right, looking at number 3, I want you guys to use analytic methods to find the intervals on which the function is. We're just going to go through A through D, where the function is increasing, decreasing, concave up, and concave down. So go ahead and pause the video and give that a try. All right, so if you're ready, resume playing. If not, pause the video again. But the first thing we want to do is find the first derivative, and that's going to become a negative 3x squared minus 4x. And we want to ask ourselves, where is our first derivative equal to 0? Where is it undefined? Well, because it's a polynomial function, it will never be undefined. To figure out where it's equal to 0, we just set it equal to 0. And we are going to factor. Let's factor out a negative x. And if we do that, though, we have to be careful with our sign. So we'll get a 3x, but then a plus 4. And you can always double check. If you distributed that negative x back in, you get a negative 3x squared and then minus 4x. So if negative x, we set that equal to 0, that just means x equals 0. And then 3x plus 4 equals 0, x would equal a negative 4/3. So there's our 2 critical numbers. So we'll write out our number line, label it our first derivative, put our 2 critical numbers on here. And I'm going to go back to this factored version of our first derivative to test some values here. So negative 4/3 is negative 1 1/3. So let's try negative 2. So if I plug in a negative 2 here, this is the opposite of negative 2, so that becomes a positive 2. And then 3 times negative 2 is negative 6 plus 4, so that's negative. So we get a positive times a negative, which will give us a negative. Let's just try a negative 1. This will give us a positive, the opposite of negative 1. And then 3 times negative 1 is negative 3 plus 4, so that'll be positive. So we get a positive times a positive. So in between those 2 numbers, we get a positive. And then let's just try a positive 1. This would then become a negative 1, and then this would become positive. So negative times a positive is negative. So this tells us f is decreasing, then increasing, and then decreasing again. Let's go ahead and find our second derivative. Looking back up here, this will give us a negative 6x minus 4. Where is this going to equal 0? When negative 6x minus 4 equals 0. So we'll add 4, divide by 6, so we could say this will be a negative 2/3. Will it be undefined anywhere? No. So we'll make our second derivative number line. All right, so let's choose a -1. So if we got -6 times a -1, that's +6 minus 4, so it's positive there. Let's try a 0. That would just give us a -4. So negative, so that tells us F is first concave up and then concave down. So to answer each part, we'll say increasing. We go back up here from -4/3 to 0, decreasing from -infinity to -4/3, and then from 0 to infinity. Concave up from -infinity to -2/3. Concave down from -2/3 to infinity. So hopefully you guys are okay with that problem. Now let's just try one more. Here I'm asking you to use analytic methods to find the relative extrema and where they occur. I don't want you to use a calculator here, so this would be a question on a non-calculator part. I will tell you though, I know I've gone through the second derivative test for extrema. That really helps out the most with what we're doing from section 4.4 when we're trying to show if we're trying to maximize the area or perimeter or minimize like surface area. That second derivative test is going to be helpful. We really don't need to use it on this test, and we really don't want to use it on this one because our original function is a fraction, so we want to use the quotient rule. So in this, my advice to you and a hint is just find the first derivative, then use the first derivative number line to justify your work. So pause the video, give this a try. Again, you want to just figure out the relative extrema and where they occur. All right, so if you're ready, let's take a look and see what you got. So using the quotient rule here to find our first derivative, we have low d high, which would just be a -2x, minus high, and then d low would give us a 2x, all over low, so we get x squared plus 3 squared. All right, so distributing this -2, we'll get a -2x squared minus 6, and then this last part will turn into a plus 4x squared, all over our denominator. Combining our like terms up top, we'll get a 2x squared minus 6 all over that denominator. Now what's going to be helpful when we go to ask ourselves the two questions is to factor the numerator, especially when we do the first derivative number line. So I'm just going to factor out a 2. We'll have x squared minus 3 over our denominator. Now I want you to take a look not only at the denominator to our first derivative, but go back up here to our function. We have an x squared, so no matter what you square, it's going to be positive plus 3. So our denominator is always positive, and that can be pretty helpful. So let's figure out where our first derivative is going to be equal to 0. That's going to happen when 2x squared minus 6 is equal to 0. We could solve by factoring, or we could just use inverse operations here. So we add 6, divide by 2, and then x will equal plus or minus radical 3. Will this be undefined? And so we're going to go back to the fact that it's always positive. It will never be 0, so never. All right, so as we go to make our first derivative number line, our two critical numbers are negative radical 3 and radical 3. Now it's not quite 2 because the square root of 4 is 2, so we could use some test values here of -2 and 2. And I'm going to substitute it back into this step. So imagine we're testing a -2. Well, this will become positive, minus 3. So this will become a positive 4 minus 3, which is positive, times 2 is still positive, and our denominator is positive, so that's going to be positive there. Let's say we tested 0. This would become a -3 in here, so our numerator becomes a -6 over a positive value, so we're negative in between. And then we should be positive over here as well. If we tested a positive 2, we would get a 4 minus 3. So positive 1 times 2, everything's positive here. So this tells us our function is increasing, decreasing, and then increasing again. Now we could even make a little sketch of the graph here, just showing this. Just to show we have a relative max here and a relative min here. So we need to evaluate f of negative radical 3 and then f of radical 3. So again, f of x was equal to negative 2x over x squared plus 3. So we're going to say f of negative radical 3 becomes negative 2 times negative radical 3 over negative radical 3 squared plus 3. This gives us a positive 2 radical 3. This will give us a positive 3 plus 3, so then that's over 6. And then we could simplify the 2 with the 6, so we get radical 3 over 3. And we should just get the opposite here for f of radical 3. This will give us negative 2 times radical 3. And in our denominator, radical 3 squared plus 3. So we'll get a negative 2 radical 3 over 3 plus 3. So we'll get a negative radical 3 over 3. And notice that's where we have our relative min. So we're going to answer this by saying we have a relative min, which is y equals negative radical 3 over 3 when x equals radical 3. We have a relative max, that is y equals radical 3 over 3 when x equals negative radical 3. So definitely a lot easier to use the first derivative number line. Because if this is our first derivative, imagine trying to find the second derivative for that. Not nice and easy. So I hope these problems were beneficial. Please look over them again, study everything else that you have as far as the quiz over 4.1 and 4.2, the team quiz that you guys took, GIF 4.1, plenty of examples that we've done in class as well as your homework problems. And let me know if you guys have any questions.